Good morning. Welcome to another episode of Xa Talk Show. Today we're gonna code Wolfram language. I'm going to introduce you Wolfram language association list, or simply called association, and which means Python's dictionary, Java or JavaScript's map object, or in Ruby and Perl it's called Hashtable. So Wolfram language association. Okay, let's begin. If you have questions, ask me, okay? If you are watching offline, skip around. Play at 1.5 speed. Okay, go to the website, search for Xa Wolfram language tutorial at xali.info. You'll see it. So in the past month, I've been working on this a whole lot, so a huge amount of update. Wolfram language Xa programming blog. Okay, so you can see Wolfram language association. So the entire association section has been updated. So let me start to show you some demo. Okay, Wolfram language tutorial. Close that. Talk show. Okay. Wolfram language tutorial. Put the link there. And go to it, open it, and go down, then you'll see association. Now association, remember, it's like a hash table or dictionary or map. Different languages have different names for it. Now in Wolfram language, it's called simply association, okay? Now in Emac Lisp, you also have similar called association list. But in Wolfram language, it's simply called association, even though it's actually like Emac Lisp's association list or Common Lisp's association list. Okay, so but anyway, it's a hash table or dictionary. It's ordered. Okay, so in Wolfram language, it's ordered. So let me start to show an example. So here is my article. You can see association, introduction of the association data structure. And then you can see a lot of articles. So you got association, how to create it in different ways, systematically, or generate association, or get value, check a key exists, check value exists, and so on. So it's a list of pairs, okay, usually called key value pairs. Okay, now go here, copy the link, go back here and paste the link there. And let me begin to show you. Okay, so association. Okay, so association, by the way, so pop it up, association. So you can see this is the syntax. So you have association, then you say A arrow 1, comma, B arrow 2. So that means the key are A and B and values is 1 and 2. Evaluate it. So you can see this is a result. I mean, this is just like literal expression for the key value pair. Okay, so you can put the result here. So what is this? Why it doesn't print that? Because this is actually the alternative syntax. This is the short syntax. For example, I can say, now let's change it to string A and string B and some value. Okay, so some value. You know, you can do it like that. So evaluate the current line. You see, it print out like that. You know, so this is just a short syntax. This and that is actually exactly the same, because in Wolfram language, when you write this and you run it, the compiler will actually first turn it into this syntax. So they are like 100%. They are just syntax equivalent, okay, syntactically equivalent. So this is association. This is a literal expression, and so now let me introduce you. So what I'm doing, so in Wolfram language, let's start it, okay? Now Wolfram language is free. You can download it. I highly recommend it because it's a magnitude higher level. It's the highest level programming language than all existing Python, Ruby, Perl, PHP, Java, Golang, Rust, Clojure, Common Lisp, Emacs Lisp, Haskell, F#, or Camel. Then all of them, obviously C and C++, they are kind of low level, and Rust, low level, the so-called system languages. You can eliminate them because they are low level, So Python, for example, Python is the most popular. So Python is fairly high level. One line of Python equals to 10 lines of C or 50 lines of C, right? Now, one line of Wolfram language is equals to 10 lines of Python or 1,000 lines of Python, literally. Why? Because Wolfram language, by default, it has 7,000 functions built in. Okay, so you can download it. Let me just quickly intro. Okay, you can download it. Just search for Wolfram language tutorial. Then you can see download Wolfram engine, and you can read about the differences. Wolfram language, Mathematica, Wolfram engine, Wolfram script. What are the differences? Are they just synonyms? You can read about it. You can download free, or you can buy the Raspberry Pi. It is bundled with a Wolfram language. Okay, so download it. Then you can, for example, I bought they sent me a copy. Okay, I'm sponsored by Wolfram Research. I've been coding Wolfram language since 1994, and I worked for them for a while. So 1994. Okay, so I've been coding it kind of on and off for like 30 years. Okay, so Wolfram language, you got so for example, let me show you association. Let's paste it there, shift enter, there it is. This is how it looks in Wolfram notebook. This is what you get when you pay to buy the Mathematica or Wolfram language. Now if you want to download it for free, you run Wolfram script. Okay, so let me show you. Start Wolfram. We don't want Wolfram desktop, Wolfram kernel. Wolfram, this is what you get if you download for free. Okay, so run it. So you can see it's a command line user interface, and you can copy that, paste it here, Control V, enter. You see? So it's the same thing. Now I'm running it. So for example, in here, let's remove that. Evaluate it. Problem. I got a problem. It says problem because I cannot run multiple copies at the same time. So I need to exit here. Okay. Now back to Emacs. Run this. You see? Same result. Now I'm running, so this Emacs, there's a XAR Wolfram mod package you can download for free that runs the Wolfram language code in Emacs. It calls the Wolfram script. Okay, so let me show you how to get that. So for example, I tab R to eval the current region, tab to jump to the source code. So here's a code that let me run Wolfram language in Emacs. So go to the top, you can see this is a package. This is XAR Wolfram mod. Okay, go to the top and there's a URL showing browser. Search for XAR Wolfram mod, you'll find it. It's on GitHub. Okay, so GitHub, just download it. Am I doing good? Audio check, video check. Say hi, guys. So let me check audio, video. Yeah, I'm good and alive. Okay, so Wolfram language association, fantastic. Now let me start to show you the power of the Wolfram association. Remember, I said it's the most high level by a magnitude than Python. So today you can check what I'm about to show you, the Wolfram language association, like Hashtable or dictionary features. You can compare to Python, Java, JavaScript, or Ruby, or whatever language you know. You can immediately see how the higher level and rich features in Wolfram language than the version of dictionary in Python. Okay, and today it's gonna be short. I plan to be just 20 minutes or so. Okay, so let me start to show you. So Wolfram language by default, you have 7,000 built-in functions. Okay, so let me show you. Question mark names to see the documentation of the function. So list of the names of the symbols. Okay, so let's try names, and you need yeah, and okay, let's magnify. So names, then quote, then let's say string, then that will return a list of all functions with the name string in it. Okay, so now let's try that again. Control L to show the last. So this time we list all functions. So this is gonna be a list of 7,000 of it. Okay, Shift Enter. So you know you got a bunch of symbols. Then you see 7,000 of it. You can see the scroll bar. You know, so it's gonna be endless. Okay, 7,000 built-in. So when, for example, if you want to traverse the directory, or if you want to use regular expression, or if you want to open a file, close a file, or if you want to do networking, or if you want to grab a URL, HTTP or web-related functions, you don't have to load a library. Like in Python, if you want to use regular expression, you have to import something. If you want to traverse a directory, you have to import system, import system file, something. So in Wolfram language, you don't have to do that. Every 7,000 functions built in. Okay, it's not in libraries. Then you do have libraries, so that's even more. Okay, so let me show you. So let's see. Let me show you. Okay, Control L. Then we // then we say length. So length, they'll tell you how many items in it. / is a postfix notation, so you don't have to like bracket, and you don't have nesting. So Shift Enter. So 7,540 symbols built in. Okay, now minus some of these, any symbol starting with a $sign, that means it's a global variable. It's a built-in variable, usually related to configuration. Okay, so you got lots of them. But altogether you got about close to 7,000 functions. Okay, so all these are functions. All these are functions. So let's look at association. Now I'm gonna read a comment in a bit. Okay, so association, here's a literal syntax. Then I want to show you some of it because I just give you an idea, and that's it for today. Okay. Let me read a comment. I don't know. Hi, I don't know. I haven't seen you for a while. That's an interesting question. Let's digress just a little bit. Okay, have you heard of Janet? It's like Clojure, but without JavaScript, without the Java virtual machine baggage. So let's look up quickly. I've seen it, with that girl picture. So I haven't. So I've heard of it like a year ago or so. Someone showed me. Janet is a functional and imperative programming language. It runs on Windows, Linux, Mac OS, BSD, and should run on other systems with some porting. The entire language is less than 1 megabyte. Oh, okay, good and bad. Whenever they say that, usually for industrial languages, that means good, because people like things to be small, so you can, for example, embed it in some portable device or phone, and it's small. But that also means right away it's not gonna be powerful like Wolfram language or Common Lisp. So lots of things you have to do. You have to either import a library, either building or from somewhere. So anyway, you can also add Janet scripting to an application by embedding a single C source file. Okay. Yeah, okay, Janet, lots of new languages today, but one of the problem with new language, okay, I'm starting to digress, but let's, so one of the problem with the lots of new languages is that you want a language that's gonna be persistent, massive number of users, so that is acceptable in industrial use. For example, it will be possibly chosen by Google, Facebook, Microsoft, or any other big corporations. Okay, you don't want a language that's one man's show. So right now, this Janet language looks like a one-man show. I don't know for sure, but it looks like it because there's lots of it like that. One-man show. So what happens with one-man show? Well, maybe you got 1 million users. Million is actually small, okay? Like fans, like me, we interested in different languages, but it's gonna be a toy forever. For the next 10 years, for the next 20 years, for the next 30 years, and then it dies, something like that, okay? So there's a lot of this little language. Nim is another example. Nim, there's quite a few today, okay? So, but, I mean, nothing wrong with it, but it's somewhat hard to become a widely accepted industrial programming language. That's what you want to be. Okay. Otherwise, it's like this, like 10,000 academic languages, 10,000, like almost literally. I mean, well, practically there are a few hundred. Okay, academic languages. They do things you never heard of. But so yeah. So I mean, with respect to practicality, or with respect to your personal career choices, you want to pick a language that is possibly or part of the industrial languages, okay, widely used. For example, Wolfram language, it is not exactly industrial. Like you don't see Google, Facebook, or Microsoft or Amazon use it. But actually, Wolfram language is special because all the physicists, mathematicians, the people who design rocket engines, who design car engines, they are all using Mathematica, okay? I mean, so this is like outside of the typical programming arena. Those people are engineers, physicists, mathematicians, engineers. They deal with equations, differential equations. They need to solve heat equations, engine, heating, all sort of problems, okay? So this is kind of actually different from typical programming like web or Linux kernel crap, predominated by the bit diddlers like the C and C++ and Rust idiots. Okay, back to the association. Then we're gonna, a few minutes, let's wrap up, okay? So Wolfram language association, you can so there are many different ways to create association. Let me just give you just a few examples. Okay, so this example is about creating an association from a list. So let's say you have a list of keys. So list 1, 2, 3, a list of keys. You want to turn it into an association, a list of pairs, and these are keys. So you can do that by just using this association map, okay? Okay, so here is your list, okay? Takes 2 arguments. The first argument is gonna be a function, and the function will be, let's say, identity. Let's say x return x. So the key and value will be the same, okay? So now if I run this eval region, you can see there is a result. So let me paste the result under it. There it is. You see, let's say so let me show another example. So you want to, so these are keys. They are okay. So value, let's say +1. Let's say squared. Okay. Eval the line. There you go. Key 1 is 1, key 2 is 4, key 3 has a value of 9. Okay, so that's one way to create association. Of course, you can do this in Python. So next, association thread. This is to allow you to have a list of keys, a list of values. You want to some kind of merge them so they become key value pairs. Okay, so example. What is this? Association thread. Okay, so again, 2 arguments. The first argument is a list of keys. Okay, let's say A, B, C. Okay, those are, let's make it string. So the keys, by the way, in Wolfram language, key and value, they can be any type. So the key can be a string, or it can be just a symbol, okay, like A or AA or whatever, like symbol, because like Lisp, it's a symbol. Or it can be a string, okay, so let's use a string. The value is, let's say, 1, 2, 3, okay, so if you run that, then you get that. Okay, so these ABC are keys. Wolfram does, when Wolfram language prints a string, those ABC are strings. The Wolfram language doesn't print the quotes, so it's kind of easier to read. Okay, so here is the example. So let's skip to next. So that's 2 ways to generate association. Okay, there's lots of other ways. So you can get value. Obviously, there are several ways to do it. Look up. Let's try. Okay, so let's try it. So let's say that is association. Many ways. Okay, one way. Let's say XX equals to. So here's association. Then you just XX. You want to get the value of A. Okay, so actually you need to. Okay. Eval region. There. What? The expression cannot be used as part of a specification. Why is that? Part spec, the expression cannot be used. Okay, so yeah. Okay, so there's a little issue. Okay, so let me explain. So if your keys are strings, okay, if your keys are strings, then this works fine. Okay, you see, 1. Let's try B, okay. You see, the value is 2 because the key for the key B has the value of 2. Now, however, if your keys are not strings but symbols like that, for example, let's use AABB, okay, to make it more not ambiguous. Okay, so the keys are now symbols. In fact, keys can be arbitrary expression. This can be a key too. So it can be actually arbitrary. Okay, so actually let's save it to. Okay, so let's go back here. Let's just say key BB. Okay, so you got AA and BB as key. Now, then you want to extract the key BB. Okay. Now, when you do that, you need to say, instead of that, you need to say this. Okay. You need to actually say key, because that prevents ambiguity. Because this, you see, this BB could be a list. So when you don't say, if you don't specify the key, you don't say it's a key, then it's just become a list. Then this syntax becomes extract a list of keys. So that's why So this is actually the normal way to do it. Okay, so let me show, let's run it. Okay, 2, you see. Now, but if you do it this way, it'll give you a warning. Okay, let's try it. You see, warning. The expression BB cannot be used part of a specification. Why? Because it is not a string. So if you have something like an arbitrary expression as key, you need to say, put a key in front. Okay, so this is one of the way to get the value from a key out of association. One way. Okay, so another way is this lookup. This is more explicit, and I prefer that way. Okay, this way we just introduce is more common, like when you are in Python, Ruby, Golang, typically you are familiar with this form, because that's the form how you extract array elements. But it's actually not good. Okay, relative to the functional approach. The functional approach is lookup. Okay, so lookup, you want to look up. So let's define the association there. Then you want to look up the association XX, and what key you want to look up? B. Okay, so let's run it. 2, there it is. Correct? Yes. Okay, so lookup is a good way to extract elements. Okay, so there are several ways, so this is another way. Oh, you don't actually need the double quote. I mean, it's yeah, I forgot. Let's try it. Yeah, you don't, that's my mistake. So if you let me see, do you still get that error if you run it? Yeah, so you don't actually get an error even though it's a symbol. But anyway, what we talked about this key thing is still valid. This is valid when this BB is an arbitrary expression. For example, let me show you. Okay, so remember, any key can be any arbitrary expression. So now let's make it very arbitrary. X squared plus, how do I type plus? It's one part. Okay, plus y squared divided by z. Okay, so now you got a key. So let's make it easier to read here. So you got 2 keys. Okay, one is just AA symbol. The other thing is this like expression. Okay, so can you evaluate it? Yes, run it. Let's make it print. Okay, run it. There it is. There's your association. Okay, now, okay, so now if you have this association, then if you want to extract the key, now it becomes a issue. Let me show you. Okay, so right, you want to extract from XX and this key, you're gonna have a problem. So let's run it. Oh, that still works. Okay, that still works. Well, I can show an example. It's gonna be a problem. So let's do it again. Let's say this time is 1, 2. Okay. So the key is this expression of 1, 2. Okay, run it. That still works, I guess. Yeah, that still works. Yeah, but anyway, so there would be a case when this just won't work. Okay, so do I have an example here? Yeah, there it is, the example. Okay, so yeah, this works. Okay, so let's say you have a key actually of 1 and a key of 2. Okay, so here is your association, and you want to extract the key of 1, 2. So let's give it some different value. Okay, key 1 is 88, key 2 is 42. Then this key list of 1, 2 is what is 2. Okay, so now we extract this key. Let's see what happens. 2. Okay, that also works. Yeah. Okay. Anyway, yeah. Let's not dig a hole of that. Just understand that this ambiguity happens. Okay. I'm not gonna spend time to actually find an example. So anyway, there is association. Then you can check the key exists. Then you can check a key exists by pattern. Now this is new. You don't see it in Python or any other language. Not in Python, Java, JavaScript, not even in Haskell or Camel, F#, or Lisp or Clojure. Why? Because in Wolfram language, remember the key can be any arbitrary expression. It can be like 1,000 lines, a mathematical equation or differential equation or whatever. Actually, we can show an example. Okay, so let me show an example. So let's just say a single key. Okay, so this key will be, let me show you this. Okay, so so we got that, and we raised to the third power. Okay, that expression raised to the third power is that. Okay, but now you want to expand it. Okay, expand that. You got that. Okay, and you can put that. In let's see. Let's put that in the association. Okay, so this is the expression. Okay, so I mean the key. Okay, let's see it actually expand the key or not. No, actually, keep it symbolic. It doesn't expand. But if you say this, I think it still doesn't. Okay, so let's try. I need a auto formatter. I don't have it. Let's run it. Oh, it does. Okay, so you see now you got an association of one single item, and so the key is this line. The value is simply 2. You see, so the point here is that the key can be arbitrarily complex. So when you have this situation, then you have a association where you have, let's say, 1,000 items, and each of the key is a math expression like that. Okay, now you want to find all keys where it contains z in it. Okay, you see, you want to find any of the key that contains z in it. That's when you want to use the check key exists by pattern. Actually, this just check key exists, but actually what you want, the way we are talking about it, is to get all keys or all values that are by a pattern, okay, which you go here. Association, delete items by filter. Okay, so you can delete or filter, take the things you want or remove the things you don't want, either way to speak it. So filter by key via list of keys, that's one way to do it, or filter by key via a function. So if this function returns true, that means keep it. If it returns false, that means ignore it, okay, via a function. Or you can filter by values via a function, okay? So here you filter by key, you can also filter by value via a function. Or, okay, where's the pattern? We want to filter key by a pattern, okay? Wait. There, delete item by key, okay? Key, okay. This is delete by literal key. Association variable delete by key. Okay, so where is that filter by list of keys? I want to filter by key and by a pattern matching of the keys. Okay, filter by key, list of keys. Filter by key via the function. Filter by value via a function. Wait, there's a filter by key via a pattern. Now where is that? Okay, so anyway, we are about to end. That's my introduction to Wolfram Language Association. But let me just find the things we want. Here. To list of rules, to all keys, to all values, get all values, get values by pattern matching on values. Okay. Wait, I want to filter a association by a pattern matching on the keys. So I want to check each key if it contains a pattern. Now where is that? Did I miss a link here? Get items, delete items by key. Okay, so this is by literal key match. Now, because association is ordered, therefore you can also delete by index range or extract by index range. Okay. Now, but I want filter. Right, so is it in the map? Oh God, I'm stumped on this thing. I want to filter by value. Why is that? You got an association, which is a list of key value pairs. Now the keys can be, each key can be arbitrary symbolic expression, like complicated math formula. Okay, so of this association, I want to basically delete any key value pair such that the key does not contain X. I mean, the key does not contain Z, okay? So I want to do some kind of filtering, okay? So some kind of filtering function. So it should be here. And this filter needs to be by a... Oh, okay, so I think, well, you can do it by a function, and the function is simply match Q, which means it match your pattern. Okay. Okay, I think that's it for today. Okay, then, so as to our question, we can do it this way. Okay, so let me show you. Filter by key. So copy that. So now, so this is association. Okay, let's put it like that. xx equals to this association, and then you say key select. Okay, now it needs a function, so here's a function, so it selects the even numbers keys, right? Okay, but now like we said before, we don't want, you know, we want a pattern. So you're gonna need, so here's how to do it. Okay, so you write a function because it requires a function key select. Then you want to say match q. Okay, so when this return true, that means it's valid. So let's say one of the key is xx squared, then z third part, then 3z. Okay, let's just say that. So we got this association. Okay, now we want to filter by if it contains z or not. Okay, so match, what is the syntax for match? Check expression and form. Okay, so again, two arguments. Expression is the x and form is simply z. So this will return just this, it will return an association containing just that entry. Okay, let's try it. Empty. Oh, because this match means whole match. Okay, so it needs to match the entire expression, not just that. So you need some kind of, so again, you need a pattern matching that matches a sub part. We can easily do that, but then we need to look into a little bit. So let's look into. Okay, so let's go to pattern matching, symbolic pattern matching. Okay, click on that, and we want to say if it contains, okay, pattern matching functions. Okay, not this. Okay, so this is pattern matching syntax. Go to the introduction to pattern matching, then go to the pattern matching syntax, creating rules to match, to transform expression, function transform expression by pattern, other functions using patterns there. Let's see. So replace or set delayed cases, position member q. That's right. Okay, so any member of a list matches a pattern? No. Okay, let's look at match q. Okay, yeah, so match q checks only match the entire expression, so you need to just oh god, we get into a pattern matching problem, but let's finish this and that's it for today. Okay, so we want to match a pattern. Now the problem is, let me explain. We have a pattern like that, or any arbitrary big expression. We have an expression like that. We want to have a function that to check if it contains z anywhere. Okay, how do you do that? So you can use match q. Okay, so this is a separate problem. Let me just try it there. Okay, so you can use match q. Now, does match q has a option? No, it must match the entire thing. but what is the way to just so far so good? Oh, this key. Oh, I didn't know that common list. Yeah, so it's very interesting because Wolfram language is like, it's just a Lisp, okay? Because in every aspect, for example, even compared to Emac Lisp, which I know very well. I know Wolfram language very well for 30 years. I know Emac Lisp for 16 years. Been coding it every day. So it's like every aspect in Emac Lisp, there's a corresponding part in Wolfram language. Just like even the association we are doing today, like in eLisp, there's an association list, which is, even the name is like similar. But this Emac list association list is not really good, okay? But it's like a hybrid between list and hash table. Then Emac Lisp has actual hash table. But in Wolfram language, it's just simply association. So it's like association list, which is ordered, can act as a list. You can you can just treat it like a list. Any function that works on list will simply work on the values, okay? But it also functions as a so-called hash table implementation or map, where you can have millions of items and it's very efficient, okay? But not so with the Emac Lisp association, because that every time you want to search a key, you actually have to search item by item. So that's Emac Lisp. So you mentioned about a key in Lisp. I'm not too familiar. Oh, that's not like Lisp quote. That well, in some way they are similar. But anyway. So what I want to say, so we have an issue, yeah. So we want to have arbitrary. Okay, so the question is, when you have an arbitrary expression such as that, or plus any just really arbitrary expression, z y squared, okay, like this is one expression. You simply want to have a function to be able to tell you whether z is in it. Does member q work? Okay, let's try that by the pattern z, okay? Run it. False. Why is it false? I kind of know why is it false. Because there's actually no item that is the that is just a z, because this actually becomes time 3 and z, okay? And yeah, well, okay, it actually gets a bit complicated. I can explain, but it takes more time, so you see this level spec, that's what you need, okay? So let me show you, okay? So this is false, but now if you say level spec from 1 to infinity, okay, run it. True. You see, that's what we need, okay? So go back here. So actually you just need a function, actually member q, okay? So actually you need this, okay? So copy that, you need that. And so you need, let me show you. Okay, so key select from the association X. How do you select? You select by a function, this function. Okay, by this function, the argument is X. And what does it do? Well, it checks if it's a member Q. So member QX, if it contains Z, but you need to check it from the tree depth level 1 to infinity, meaning that you check not just the leaves but also the intermediate nodes, and gets a bit complicated. It's because we are dealing with keys that are arbitrary expressions, meaning that each key is arbitrarily nested tree. And we are trying to pattern match the tree. So that is why you get a bit complicated involving this, So, but anyway, this will work. Okay, let me show you. So delete that, remove. Okay, so here's the thing. Okay, we got an association where the keys are arbitrary complicated expressions. We want to extract the association only keys that contains the symbol Z. Okay, that's how you do it. You say key select, takes 2 arguments, the association and a function. So here is our function. The function takes X argument, then check member Q of X, check for Z, and with these levels, tree depth levels. Okay, run it. You see that? Fantastic and beautiful. That's it for today. Thank you guys for watching. Finally, thank you. And we're done. Did you enjoy it? Did you guys learn something? Okay. If you like it, pay me. This is important. Okay. Despite me repeating. So check out my Wolfram tutorial. Just search for Wolfram language. You can download it free. Search for Wolfram language. Okay. And then go up. Then you see all the programming language tutorials. Go to xali.info homepage, XA code. And all the way bottom, you'll see PayPal, Patreon, Amazon gift card. Okay, so pay me. Thank you guys, and good afternoon. Bye. So put this back, color it, show in browser. That's what we talked about. Fantastic. Close it. Member Q documentation, close it. Janet language, interesting, but this you see, this programming language, I can tell right away it's a one-man show. Okay, why? Because first of all, it's got this icon, a woman icon. Yeah, it's pretty nice. It looks, she's fairly good looking, but if you want a professional programming language widely adopted, that is a no-no. Okay, that's a no-go. That's because how do I know? Because I know, diverse kind of things. Okay, so this is related to logo design. One of the rules of logo design is you don't want complicated pictures. You want simplicity. Okay. You want something on icon that people can recognize. So that's one violation of logo design. This women, beautiful, too complex. A logo is not just like a painting or artwork. Okay, so that's first violation. Second violation, you don't use a generic women to represent your language like a logo. Okay, logo needs to be symbolic. And symbolic to whatever your company is doing. So McDonald's, for example, it's got an M. M reminds you of McDonald's. Shell Corporation, it's got a shell, seashell. Oh, shell. Reminder. Taco Bell, it's got a bell. Bell. Oh, reminder. Taco Bell. There's a bell. What is this Janet language? Well, a girl, a woman named Janet. Like what the fuck is this? So that's the second violation of logo design. Okay. I mean, it's no big deal, right? But it just tells me that this language is like one man show. He's just a nerd somewhere. He doesn't really know about the principles of logo design, or he doesn't have money to hire a logo designer. Well, today logo design is pretty easy. You can ask AI bots to create a logo for you. But he doesn't know, apparently, he doesn't know the principles of logo design. So if you are a corporation, you are not, you look at this, are you going to like put this women picture in your corporation's, like tools? No. So that's the same thing, and lots of other issues with this one-man show kind of language, okay? Calvin Rose created it. Okay, anyway, interesting though. Okay, bye guys. Bye.